Hello everyone. Let's discuss this theoretical problem which may be asked to you in the various interview like BARC or IOCL. The question is, what conditions are necessary for the formation of a solid solution alloy? Okay, so we know that solid solution alloy are basically prepared by melting the metals and blending them to form a homogeneous mixture. Suppose we have metal A and metal B. They are first, melting process is done, and after that we blend it to form a homogeneous mixture that will form the solid solution alloy. Okay. To form a solid solution, the atoms of these two metals, that is metal A and metal B, should have same size, should have same crystal structure, and their chemical properties should be similar. So that is basically given by Hume-Rotheray conditions. So what are the conditions? They should have similar size, okay. Size difference, okay, should not be greater than 50%, it should be less than 15%. Okay. They should have same valence electron, okay, same crystal structure, and one more we can say similar chemical property. Similar chemical property. Okay. When A and B will form alloy, that is a solid solution, there will be a bond between atom of A and atom of B. It is just similar to, this bond is metallic bond, and it is just similar to, the bond between the atoms of a non-metal or metal in a covalent molecule. So it is similar to that. Like suppose if we take an example of water, that is H2O. So this is a molecule where oxygen and hydrogen has a covalent bond. Similar to that, there is a bond between atom of metal A and B in this alloy. Okay, so it is similar to that of covalent bond, but it is metallic bond, it is covalent bond. Covalent bond is formed by sharing of electron. So we see some example now, and will relate these conditions with the solubility. Okay, so if we take an example of gold and copper, okay, gold and copper will form a single phase. They are soluble in all proportion. Okay, they are forming a single phase all the way from 100% gold to 100% copper. 100% gold to 100% copper. It is a single phase. Okay, it means they are completely soluble in each other. Then it must be following the Hume-Rotheray conditions. So let's see. If we see the metallic radii of these two metals, gold is 144 picometer and copper is 128 picometer. Okay, so size is similar. Size difference is less than 15% approximately. So first condition, this alloy is following here. Now, they have same crystal structure. Both are, gold is also FCC and copper is also FCC. Okay, so both are FCC, so they also have same crystal structure. Both are metallic, okay, and their reactivity is very less. Okay, so they have similar chemical property as well. Both are less reactive. Gold is least reactive, or we can say most inert metal. So because of this, there is a complete miscibility of gold into copper or copper into gold. Okay. Now if we take another example, that is lead and tin. Okay. If we see their atomic radii, lead is 175 picometer and tin is 162 picometer. So in this case also they have the similar size because the difference in the atomic radii is less than 15%. So they have the similar size. But the problem is what? Lead is having FCC crystal structure, okay, where tin has a complex arrangement. It's a complex packing arrangement. So the crystal structures are not same here. Okay. So due to that reason, the solubility of tin into lead is not very high. Okay. So solid solution of lead and tin is not possible, okay, with more than 20% tin. This is not possible. For less than 20% tin, it is only possible, not more than 20%. So it is clear that here the solubility is not good. Reason being, they have different crystal structure. So they are not following that Hume-Rotheray conditions. Okay. Now, let's see the next question. Suggest any two reasons why zinc and potassium are unlikely to form a solid solution alloy. So basically, already we have discussed to form a solid solution alloy, they should be having similar size. But if we see the size of potassium, potassium has the symbol K, it's alkali metal. Its size is too big, alkali metal are bigger in size. It is 227 picometer. So atomic radii is 227 picometer, whereas zinc is a D block metal and its size is less. It is 133 picometer. So zinc is like it is very less as compared to potassium. It is just like half. Okay, so it is very less. So size difference is here, we can say size difference is greater than 15%. Yeah. So the first condition of Hume-Rotheray is violated here, not satisfied here. Okay. Now, if we see the another conditions of forming a solid solution alloy is they should have the same crystal structure. So now, if we see the crystal structure of potassium metal, this is BCC, body centered cubic, BCC. Okay. And if we talk about zinc, zinc is basically HCP, hexagonal close packing. It is very brittle, okay, HCP, because of less number of slip planes. So again, it is against this Hume-Rotheray conditions. So we can say that is the reason, okay, for not making a solid solution alloy, for not forming solid solution alloy by potassium and zinc. If we see the another like reactivity, okay, so chemical properties, if we see chemical property, so potassium being a alkali metal is highly reactive. Okay, so this is what highly reactive. Highly reactive metal, very soft metal, you can cut it with the help of the knife also. Highly electropositive metal, easily it can lose electron. That's why it is used in, photoelectric cells. Whereas zinc is much less reactive. Okay, so zinc is also reactive but much less reactive as compared to potassium. So comparatively it is very less reactive. Okay. So again this is what against the Hume-Rotheray conditions because according to that they should have similar chemical properties. So all these dissimilarities between the potassium and zinc, okay, explains the reason behind its failure or they are not simply forming solid solution alloy. So they are explaining the reason why they are not forming solid solution alloy. So these all dissimilarity are the regions. Okay. That's all. Thank you.